Good morning, everyone. I am Nicolas Frizon. I am Technical Sales Manager for NYCO. Unfortunately, I'm not able to speak Portuguese, so I speak English today. NYCO is a French company specialized in esters in synthetic esters for industry and automotive applications, and also its historical business is synthetic lubricants for aviation and military applications. Can you switch the projector? Thank you. So before I start, I'd like to thank the Lubgrax organization for inviting me today to speak, and also our local distributor, IMCD, to make this happen. So today we'll talk about the benefits of synthetic esters in modern lubrication. So in order to do so, we'll review the general properties of esters. We'll talk about the traditional applications we can have of esters and why esters were chosen primarily. And then we'll have a look at the future requirement of lubricants and how esters can contribute. So first property we'll talk about is the volatility and the rheology of esters. Do you see the pointer? Yes. So compared to other traditional base stock, mineral base stock, or other synthetic base stock, we compared different esters and regarding different parameters. So esters will show a very low volatility and higher flash point if you compare to the others. And this is mainly due to the fact that esters are a polar species, so it will create a specific bond between each molecule and will keep them tightened together and prevent them to get volatile. Also, esters will show high viscosity index and very low pour point compared to their base stock again. This is mainly due to the fact that esters are a defined species. They are synthesized, on the contrary to other base stock which are refined. So the direct consequence is that there is no big molecule in your product creating a bad behavior at very low temperature. And on the other side, you have no very small molecule being volatile at high temperature. So that brings special properties in terms of volatility and rheology to esters. We'll now have a look at the tribology of esters. The esters, thanks to the oxygen into the ester function, the oxygen is positively charged and will have a special affinity to a metal surface. This will give esters a specific friction modification. We'll have a look at two different tests we have here. The HFRR, which gives us, compared to the base stock, a much lower friction coefficient. And we can have a look also at the 4-ball test, which will mimic a bit of load in your application. And you will see that the ester gives also a limited wear scar compared to the base stock. The affinity of the oxygen for the metal surface will prevent the esters to be squeezed away when you have some pressure on them. And that gives them specific tribology advantages. We'll have a deeper insight on the polarity of esters. Polarity of different base stocks can be analyzed by their annealing point. As you can see on this part of the slide, you have a ranking of the polarity of different chemical families. I won't go through the test in details here, but the higher is the temperature, the less polar is the base stock. So we see here that esters are part of the most polar base stocks. It brings them specific advantages compared to other base stocks. It makes them good solvents for additives mainly, and also for residues of oxidation that you can have in your applications. So, and in terms of detergency and dispersivity, esters are also very good, and we made micro-cooking tests. Micro-cooking tests is a test developed by the GFC. GFC is a French group of industrial part of the lubrication, so NYCO is part of this group. There are also French car manufacturers. And this test was developed in order to show the cleanliness you can have with esters, as well as the detergency it brings. So if you compare, it's a surface, it's a metal surface, and you can check the quantity of residue you can have, and by choosing a neopolyol ester, you will have a very clean surface, thanks to the polarity of esters. We can now have a look in details on one of the most interesting advantages of esters is their thermo-oxidative stability. The thermo-oxidative stability of esters can be divided into different aspects. The first one is regarding the reaction of the oxygen present in the air, basically. And esters are, the ester function is very strong regarding oxidation and will have little impact on the ester itself. On the other side, with certain commodity esters, you can have internal reactions, which is called beta elimination. It's when you warm up your product, we'll have this kind of beta elimination, no matter if there is oxygen in your application. By choosing specific structure, you have an example here of a neopentyl structure. It completely inhibits the beta elimination. So for these two aspects, esters are very strong regarding thermo-oxidative stability. Below the image is an ESTM D4636. It's an oxidation corrosion test we make a lot at NYCO. We use it only here to show the amount of deposit you can have with different base stock. It's a very severe test, we must say. And even with, with different mineral base stock, you have a lot of residues. Even other synthetic esters, and even commodity esters will bring you a lot of residue in your application. By choosing neopolyol ester, you will have a much cleaner surface. Here you have an example on how the raw material of esters can have an impact also. We'll detail this on the next slide with the cooking propensity. If you warm up your product, it will be stable up to a very high temperature, but what happens once you've reached this temperature? This is where the cooking sometimes happens. So you have different reactions. You can have polymerization, for example, for unsaturated ester, which will increase your viscosity. You can have a formation of hard varnish, which can be very difficult to get rid of. But if you choose a specific structure of neopolyol esters, branched acid mainly, compared to linear acid, you will have, again, a much cleaner surface. And there is nothing to compare with the other base stock. That's a very big advantage of esters in high temperature. Also, technically, esters will bring a lot of benefits, but more and more we see a lot of requests for environmental impact or harmless environmental impact and food contact as well. Quite a significant number of esters are biodegradable as such, which means above 60% regarding OECD 301B. And compared to other base stock, it is the only base stock bringing that feature. You can have even biodegradability, very good biodegradability with a viscosity of 1000 centistock at 40 degrees C. Also, the renewable carbon content is more and more an important matter, and ester, by choosing the right raw material, can bring a high ratio of renewable carbon. Not only the ester will be harmless to environment for a significant number of them, but also we need them to be harmless to human beings. And the food industry requires specific attention and specifically tailored and formulated products. A lot of ester, an increasing number of esters with many different properties also are HX1 approved and can be used to formulate H1 lubricants. So we'll now have a look, now we have talked about the general properties, we'll now have a look at the common application we can have with esters and talk why they were chosen. So the first one, and it is the one NYCO has a strong history in, is the aircraft gas turbines, oil. For these applications, because in aviation the oil will face temperature up to 400 degrees C in pack, as well as the requirement of remaining liquid at minus 60 degrees C, the ester is a mandatory base stock to answer to this request. So that's why they are the only base stock chosen for this application. The second application here is the refrigeration oil. Ester is widely used in these applications because it has the right miscibility with the gas for refrigeration, which is the HFC. Also, it shows, esters will show very low pour point and very good lubricity. The last one on this slide is the air compressor oil and the need of high resistance to oxidation with very high temperature and the limit of deposit in the application. The ester also are very good products to extend the drain interval, for example. In the past, we have seen many safety issues where, due to the residues in the application brought by mineral base stock mainly, the valve of the air compressor were getting sticky, and the several air compressors have blown up. So esters also improve the safety for this application. Two-stroke engines may make a lot of use of esters because of the clean burning properties, the excellent detergency we have seen, a very good lubricity, and also a very good biodegradability for marine application where it's mandatory, for example. So esters, compared to other base stock, have seen reduce exhaust smoke, reduce wear in engines, also the quantity of deposits, and again, a good environmental profile. Oven chain is then a very good example of where esters can bring all the benefits, because oven chain in high temperature have a high evaporation rate, a very strong thermal degradation, and also again the formation of residues very easily, and safety is still an issue everywhere for the industry. So synthetic esters, thanks to the very low volatility, high flash point, the high fire point as well, also the high resistance to thermal oxidation and the low deposit formation, they have solved a lot of issues in this application. We'll come back in details on the future of this application later. So that's the idea of what usage is made of esters nowadays. and why it is a very common base stock use in the lubrication industry. We'll have a look now in details on how esters can help you or can help to formulate future lubricants or tomorrow's lubricants. We'll have a look first at the requirements as drivers of the modern lubrication. So we'll have known that better performance is more and more required, an improved durability with longer drain intervals, for instance, and for everyone, reduced costs is an important matter. Also, the OEM standards with high energy efficiency, fuel economy, and power density, making the temperature to increase a lot in these applications. And the requirement of a good safety are the biggest driver in the lubrication industry. Also, the sustainability remains an important matter for everyone. So that makes esters very good product to solve all these issues at the same time. So we've made a few exercises. The first one, we've had a look at modern passenger car motor oil, and we wanted to check how an ester can solve the issue, the requirement of lower volatility, higher thermo-oxidative stability, and an improved cleanliness. So we've taken two different engine oils, one being ACE-AC1, the other one being approved with the GF5 test program. So we've taken both. In both formulation, you have the formulation in detail here. We've taken the PAO in the formulation out of the formulation and replaced it by a neopolyol ester for the exact same viscosity and at the exact same ratio. And we made a few tests on these formulations. So the first one we made is the MCT test you begin to be familiar with now. You can compare, in red you have the formulation containing esters, and if you have a look at the metal plate here, you clearly see that there is less residue on the ones containing esters. A good way to show it is the TS33C test, which is part of the GF5 program. And if you have a look at the amount of deposits, you have a really important improvement. You have 16 versus 23 milligrams. Also, we made a TGA, thermogravimetric analysis. We apply high temperature oxygen, and we measure the weight regarding time. And we compare the two different formulations. So you need to compare those who have the same shape, basically. So if you have a look at it, the ester will improve the volatility, will reduce the volatility because you keep a biggest amount of product in your application. And also it keeps the exact same shape of the curve, which is a good sign for this application. So esters can be used in modern PCMO also to improve the volatility and reduce the formation of deposit in future engine oils. We'll now have a look at the high temperature oven chain again and what this application will require in the future. So we made, again, TGA just to detail the perfect shape of a TGA curve. You need slow evaporation on top, a very quick decomposition, and little residue at the end. That's a perfect shape for TGA. So we tested a couple of formulations. It's a bit blowy, I'm not sure you can read it. But in red, you have the traditional base stock for this application, which is a trimelitate. And if you see here, this curve shows that in these conditions, you have a very high volatility, which isn't really good because your chain isn't lubricated anymore. So we changed this formulation and we chose a neopolyol ester in blue. And as you can see, it begins to have a better volatility. You have a higher amount of product and quick decomposition and better residue at the end. We improved it by choosing antioxidant to protect it, because with the highest temperature you can have, more than 300 degrees C in these applications, you need to protect your esters. Esters are good, but you need to protect them. So an additive, an antioxidant package was chosen to improve it, and you see again an important improvement. In green, the best curve we have here, NYCO has developed an internal antioxidant for aviation application, and we chose to use it in this high temperature chain oil. And as you can see, it will improve a lot your volatility. If you compare, you have a huge gain of volatility in the application, so it remains lubricated in your application. Again, the MCT test will show that at temperature above 280 degrees C, you have a lower amount of residue with neopolyol esters. I can't change. Oh, yes. It was decided to develop an hydraulic fluid with more and more important requirements for this application, and on the technical side, and also the requirements of having a better environmental profile to meet the latest standard, such as European Eco-Label or US VGP. So 2 different formulations were developed. You have both of them here. And one of the requirements was to have a very good biodegradability, above 60%, and a high ratio, high content of renewable carbon. Sorry. So you have on one side saturated, that's neopolyol ester, and here complex ester. We made tests regarding the ISO 15380 standard, which is a common standard for biodegradable eco-label hydraulic fluid. And a lot of these tests show that esters can bring very good technical performance without compromising on the environmental profile. It has high resistance to oxidation, good lubricity, we can have a look in detail, but also high flash point, which can be required for some application, and very, very good environmental profile. So it shows that esters, regarding new requirements of power density, energy efficiency, and durability, will not compromise also on environmental impact and safety. So it makes them very interesting base stock to have a look at for modern lubrication. Thank you very much.